Hey everyone, so have you ever looked at programming and thought it was some kind of secret code only for geniuses? Well, if that's you, you're in the right place. Today, we're going to pull back the curtain and completely demystify what it actually means to write code. But let's start with a kind of a big question. What if you could actually speak to a computer? Not just by typing commands, but by giving it a set of instructions, a recipe really, to build almost anything you can imagine. Well, guess what? That's exactly what programming is.
Okay, so let's get into a really core idea here. Computers understand two kinds of knowledge. On one side, you have declarative knowledge. This is just a statement of fact. But a computer doesn't know what to do with a fact. It's kind of like, okay, so what? That's why we need imperative knowledge. This is the good stuff. It's a recipe, a how-to guide. That is something a computer can follow. And our whole job as programmers is just to write that recipe.
So really, if you remember one thing, let it be this. Programming is just writing a recipe. The computer is like this incredible chef. It's super fast, perfectly precise, but, and this is a big but, it's kind of dumb. It can't think for itself. It will follow your instructions to the letter, which is why our recipe has to be crystal clear.
Now, every good recipe starts with ingredients, right? In programming, our ingredients are just different types of data. These are the fundamental building blocks we're going to be working with.
Our first ingredient is something called a string. Now, don't let the weird name throw you off. It's just a fancy word for text. Seriously, anything you put inside quotation marks, whether it's a name, a sentence, or a single letter, that's a string. Simple as that.
Next up, we've got numbers, which are, well, they're exactly what they sound like. In programming, we just make one tiny distinction. We call whole numbers integers, and numbers that have a decimal point are called floats. That's pretty much it.
And our final basic ingredient is a Boolean. This one is the simplest of all. Just think of it like a light switch. It can only ever be on or off, true or false. It sounds basic, but this little on-off switch is incredibly powerful because it's what helps our programs make decisions. All right, so we've got our ingredients on the counter. We've got text, we've got numbers, and we've got those true-false switches. So what now? Well, now we need the instructions, the action steps that tell the computer what to do with everything. The first and maybe most important tool here is the variable. A variable is basically just a container. I love this analogy. Think of it as a labeled jar. You give the jar a name, you put one of your ingredients inside, and now you can easily find it and use it again later.
And here's what that looks like in the wild. We've made a little container, and we've labeled it character name. Then, we use that equal sign to pop the text John inside. Now, anytime our program needs that name, we don't have to retype it. We just say, hey, go grab what's in the character name jar.
Next, we have functions. So if our whole program is a big recipe, then a function is like a pre-made mini recipe for a common task, like dicing an onion. You define the steps once, you give that mini recipe a name, and then you can use it as many times as you want without rewriting all the instructions. It's a huge time saver.
For example, look at this. It's a really simple function that we've named say hi. Its entire recipe has just one step: print hello user to the screen. So now, whenever we want to say hi, we just call the name of our function and it does the job.
And finally, we have if statements. This is how we use those Booleans, our little true-false switches, to make our program smart. It works exactly how you think it would. It's just like in real life. If it's cloudy outside, I'll bring an umbrella. Otherwise, I'll bring sunglasses. It's what allows our recipe to adapt to different situations.
Okay, our ingredients are prepped, our instructions are written. I think it's time to put it all together and cook up our fun final dish.
So what are we going to make? We're going to build a simple, classic Mad Libs game. You know the one, right? Where you fill in the blanks with random words to create a hilarious story? It's the absolute perfect way to see all of these concepts in action. So here's our recipe for the game. First, we need to get our ingredients, so we'll ask the user for a few words. Second, we'll store each of those words in its own little labeled jar, a variable. And finally, we'll use those variables to build and print out our silly story.
So, how do we get our ingredients from the user? Well, we can use a built-in mini recipe called input. What it does is it prints a question on the screen, waits for the user to type something, and then it stores whatever they typed right into one of our variable jars, like color.
And here is the final step in the recipe. We use another function called print to display our story, but instead of just fixed words, we're using our variables.
That little plus sign just combines our text with whatever ingredient the user put in those variable jars. And voila! Here's the final dish. The computer followed our recipe perfectly, taking the fixed parts of the story and combining them with the user's words to create something brand new and pretty funny. It just goes to show you how even a few simple concepts can create something really entertaining.
And that really gets to the heart of it all. Programming isn't about being some kind of math wizard. It's about creative problem solving. It's the art of breaking down a big task into a sequence of really simple, logical steps that a computer can understand.
So, we've gone over the basic ingredients and the core instructions. You now have the fundamental recipe for telling a computer what to do. The only question left is, what are you going to create?